our final two workshops this year on quantitative data analysis. I'm very glad we have Dean here again to teach the class. This is a class that he specializes in. He's been using these types of causal inference methods, especially today, to learn difference and difference in his research a lot. So I'm very glad that he can teach it to you, and I'm sure you have a good workshop.
All right, thanks, Tarani. So I'll just get started. Okay, so the plan for today is pretty straightforward. I'm going to do two things. One, my assumption is that you probably know something about difference in difference, or even if you don't, I guess you know what I'm going to be covering using the empirical evidence from these four papers. I mean, from the three papers would be illustrious enough. Okay, if you have, I want to say it's not something like I'll be able to cover like in a couple of hours completely, and so you know everything, blah blah blah. But basically, this is causal inference. This is what I do for, I guess for a living. I teach at business school too. But R is something that I picked up last year, just to be honest with you, because I had to teach this workshop. So, but I want to say, a few reasonable number of lines of R codes that you can actually run and make it work, because the feedback I got from the previous couple of sessions, not on difference in difference, but on the other topics, were that I'm throwing at the student with too much information, that the collected a bunch of R codes, but people don't really know how to run. So my goal today is to actually have you basically is copy paste. Okay, you copy and paste it, and then I explain to you how you actually obtain it. I'll do the demonstration really quick first, and then I'll have you run it. But I doubt it's going to take the entire 3 hours at all. So and I don't want to keep you that long anyways. So we'll just get our stuff covered. The first hour could be a little bit, I want to say, academically not necessarily boring, but it is not that interesting. Okay, so bear with me for the first 45 minutes or something, and I'll show you. I'll do a quick demonstration of the R codes. Comes out to be easier than I thought. Okay, it's not like a state when you copy and paste, you oftentimes, if there's an error of, let's say, your input system is Chinese versus English, then there could be a little glitchy, and then you run into a lot of reds. This is basically just copy paste, and then you run it, and then it will be able to I guess produce a couple of tables. But the challenge would be to interpret the tables, like what does the table actually tell you. But having these as an example would actually help. And then on Friday, we'll do fixed effects. But even to talk about difference in difference, I'm going to incorporate, I want to say, some explanation of fixed effects as well, because in the regression model that I'm about to show you in a little bit, difference, there are elements of fixed effects to control within group variations. I'm already throwing in technical terms which may not make sense to you at this time, but that's completely fine. Okay, I guess we just go we'll go step by step, and then we'll deal with it. So the idea, I want to say the idea of difference in difference, this one is that I'm giving you an actual example. Okay, this is a very classical paper looking at the impact of wage or minimum earnings wage on employment. Okay, so this is to begin with, what's the nature of this problem? Yes, different. A very classic paper. If you are in social science, I do economics of education. That's my field. Now you would label economics, but this is going to be something I want to say you would run into for sure. Okay, so just to give you a heads up of what this problem is, suppose you're you're interested in studying both Hong Kong and then the US have this policy issue of minimum wage, and everywhere else. Okay, different levels of standard. This minimum wage is unemployment, a classic and controversial question in labor economics. Then assume that we are in a very competitive labor market, that increases in minimum wage would move us up a downward sloping demand curve. Okay, so this is employment would fall. That's kind of like the implication. Basic supply and demand in economics. I'm hoping that you actually know what's going on with this. Now, this paper, what it does is that using empirical evidence of the data to analyze the effect of minimum wage increase in the state of New Jersey. This map is not necessarily right. If at least when I was teaching yesterday, I found out this map is not necessarily correct. But I did not have time to to change it. I'm citing from someone else anyways. So, but this is basically New Jersey, but New Jersey is actually to the left of New York. So this is not precise, but gives us an idea. Anyways, the state of New Jersey increased the state's minimum wage from this much, 4.25. But keep in mind that this is back very, very long time ago, like I want to say more than a decade ago. The paper was published in 1994, so this was like a long while back in 1992. And then these days, the minimum wage are somewhere around 17.25 or something like that, 18.25. Probably, I think that's about right, yeah, or 16.75, something like that in the state of New Jersey. New York is like 20 cents higher, but not by so much. So what happens is that they are comparing two states, New Jersey and Pennsylvania, which is, our neighbor states. And then they're comparing that one of the states, New Jersey, increased their minimum wage to this certain level. Pennsylvania did not do anything. So they wanted to find out what's the impact on employment in both states and what is the effect of this policy. By saying policy, I mean the increase of the minimum wage policy. What would have happened, okay, without the policy, and then what is not happening? So we're using, you already know this. We're using this approach called difference in difference to solve this causal problem. So the experiment is that this quasi experiment, not really like a natural experiment. The experiment is that they surveyed about like 400 fast food stores, both in New Jersey and also in Pennsylvania. Remember, it's like before and after the minimum wage increase in New Jersey. So there are two time periods. Okay, in difference, oftentimes there are going to be two critical conditions we want to be aware of. One is the time difference, that before and after, and then two is treatment and control. So whether you receive the policy intervention or you do not. Okay, so that's just to begin with. Now this is the math part of that, but just so you understand what's going on. But that's pretty much it. So difference is a version of fixed effects estimate. So that's why I'm actually putting these two together, because they are difference is one of the most frequently cited and used method that has a lot of issues, but oftentimes it helps us getting to the point of making causal justification. By saying causal justification, I'm not saying 100% like difference can help us get to the stage of pinning down a causal effect, because it cannot. There are lots of assumptions to be made beforehand. There are variations of the context, and then the conclusion we draw. All of this difference estimation are providing, I want to say, at best suggestive evidence. They could not necessarily do what a random control trial can do. Like you can say that this is a causal effect. So many of the quasi experiment methods are like this. Okay, what I do oftentimes, other than difference, or I do together with difference propensity score matching. So I would actually match groups in advance to study the impact of something on something. So that's what also one of the things I do. Like for example, I study the impact of attending prestigious graduate programs in the United States. That's mostly what I haven't been using Asia data that much because I don't have access to. So the data I actually have are either restricted data from National Science Foundation in the US, or public available data from, for example, this one I use data from National Survey of College Graduates, NSCG, 2009 to 2019. So I use 10 years data to study the impact that. To do that, I want to say the reality or the challenge is that I wouldn't be able to find a counterfactual group anyways, because if I want to study the impact of the students attending institution A, which is Ivy League, versus let's say a state flagship school such as University of Michigan, both are, I want to say, great schools. I mean, with any one of the Ivy Leagues, compared with University of Michigan, just to give an example, this student can only attend one institution. That's about it. Okay, he or she cannot say, "Oh, I did not choose the MA economics program at Cornell, but I went over to Michigan State, University of Michigan." I can only find out, I don't have a way to find out the counterfactual. Same thing that difference is dealing with. So I use propensity score matching, and oftentimes I use propensity score matching plus difference difference. But essentially, difference difference is a version of fixed effect. Why do I say so? Because this is, you're looking at, I want to say, the employment at the same, this is an observation. Either it is a restaurant or individual, or it's going to be an event, whatever that is. This is going to be an individual. This is your observation, just to generalize it. In a particular state at time t with a high minimum wage versus a low minimum wage. And this is two different time periods. This is just after, this is before, noted as 0 and 1, okay? In the practice, of course, we only see one or the other. So the challenge is that we don't observe counterfactual group, okay? Otherwise, if we observe counterfactual group or the results from the counterfactual group, then that will come down to easy peasy, because you'll be able to just subtract the results outcomes from counterfactual group and then by the treatment group, and that's it. But it wouldn't be that easy because it's just like, it wouldn't occur like that. So in the absence of minimum wage change, employment is determined by the sum of the time invariant state effect and also a year effect, which is, this is going to be changing along the time. Okay, this is not going to time invariant state effect, but this is also arguable. That's why you would actually incorporate what we call a fixed effect. So you're trying to fix that within group variation. The states may have many factors other than the minimum wage to impact employment, but this is one of them. And then your treatment is going to be a dummy variable for high minimum wage states and periods. And then assuming that you will actually look at the state and time fixed effects if you were looking at them, and then the expected value of average earnings from after the treatment minus before the treatment, that would be the treatment effect. Observed employment can be written as such, as simple as this. But the question is this correct? All right, so this is a little bit, I want to say, math intensive, so I'll just skip it because I don't want to overwhelm you. But it comes down to the interpretation of what we call the difference, okay? This strategy specifically, you're basically looking at the differences of these two observational groups in two different time periods, and then you subtract the difference from the other difference. That's it. It's as simple as that. But the challenging or the complex part of difference is to make sense of the problem that you are studying. So what I'm hoping to do, or what I'm hoping that the major takeaway from today's workshop is that you understand the fact, how do you simplify the interpretation of difference, okay? Like, how do you simply know exactly what your question is that you're trying to study, and that's it. So that's one. And then now that's it. And then two, you know how to apply it in R, and that's it. And then R would be, provided to you. If you want to use difference, moving forward using R, I assume you would do so, then you can just change the variables, okay? You can change the variables and change the substitutional notes, and then you would still be able to run the codes as what we do today, and then, and do that, okay? And R is, I want to say, proved to be much more user-friendly in the sense that you don't actually have to spend too much time loading data. But the examples I provide are convenient examples because the data already being loaded. Even if it hasn't been loaded, in the first couple of workshops, you can ask for lecture material slides from folks, but there are also a lot of public accessible materials on learning R, on learning data. There are so many of those, okay, that you can actually have access to and then do it yourself. So I think that's that's going to be very helpful. So this is the looking at the population differences are like this, and this is estimate using the sample analog of a population mean. If you see what it is, okay. Essentially, if you put it in a regression table, okay, this is going to be, like I said, you're looking at the differences of two states, and then you're looking at the differences before and also after the treatment. The treatment is what we call the increase of the minimum wage, and that's it. You're looking at the mean of the employment, full-time employment, and then but this is going to be the result coming from the difference in difference. So let's not worry about the actual statistics now, but just know that this is the definition of difference in difference. You're taking the difference of two states, and then you're taking the difference from two different time periods, and then you subtract the difference from the other difference. That's why we call that difference in difference. Okay. All right. Pretty easy to understand, but very hard to implement because to understand the context that you're in, it's going to be challenging. There is one helpful reading that I actually would actually recommend you do if you want to. Here's the thing: if you want to know everything about causal inference, there are a bunch of ways. I want to say there's just like 4 resources that are going to be tremendously helpful, depending how strong you are in math and statistics, and then how personally interested you are in learning. I want to say this causal inference stuff. But I think overall, for me, I got my training from 2 resources. One of them is called, but all of them are publicly accessible. There are lots of learning materials of that, so you can do that. One of them is called Most Harmless Econometrics. This is basically explaining causal inference in I want to say most sophisticated statistical math way, but there are lots of, this is one of the, this is a really cheap textbooks, by the way, but this is when we were training causal inference to, I want to say, as early as the early 2010s, this is what we were using. But this book is challenging. I still don't understand some of the math, just to be honest. And then a couple of years ago, there is this thing called, there's this this is Most Harmless Econometrics, and then there's the same author, but they have another a little bit more user friendly book called Master Matrix, which is this textbook. Yeah, Master Matrix, and then they're trying to be funny and then come up with a couple of cartoons, but I think it's even more boring personally, that's for me, but you might have a different opinion, but I just don't get their jokes, but they are saying that they're making jokes, so you still have to laugh. So so this is the Master Matrix, but there are also a very cheap, affordable textbook, just so you know. There are lots of, I want to say, like, this is refreshing regression. You can look at their video, but I did not, because I don't find it funny. I would rather just read it. But it is a very valuable resource. I did the data thing. I took advantage of the data thing for sure, because I do replications a lot. So that's how I learn coding. Okay. What we're doing today is also replication. Okay. So this is the other. These are the 2 when we are training ourselves that we use extensively. I think these are somehow challenging, but I want to say we made it work. But in most recent years, I want to say just during COVID and also just 2 years ago, I found out one resource during COVID, and I just found out a resource from another professor. We were just chatting, and he was asking me, "Hey, have you heard about this?" First of all, he asked me that what are you using to teaching causal inference at the business school? I said I'm using Master Matrix. He said that's out of date, and then he recommended me this book called with this professor, and then I look it up. I think this is a whole chapter. There are a couple of whole chapters that you can read, and then that will be extremely helpful. This is one of them. But just before I forget, I'll just show you mixtape causal. Yeah. Okay, so and then these 4 resources, or these latter 2 resources, this one, the effect, it's just called the effectbook.net by Nick Clinton, Nick Huntington Klein. There's a whole chapter on difference in difference. You can read about it. I'm not going to be doing that with you today, because you can do that later. And they even have complete codes in 3 formats, which is completely free, accessible, and they are in I believe they are in R, they're in Stata, and they're in Python. Okay, I don't know anything about Python, but these 2 are what I use, so I find them extremely helpful. And this entire resource is for free. So if you were just to choose one book, I think this could be it. It's very easy to comprehend, very easy. It's actually a fun read. It's not very technical. They minimize the amount of math that you have to know to interpret everything. I find it very helpful. Okay, it even actually helps me to help me understand what is difference before I teach you today. This reading itself was tremendously helpful. So that's why I wanted to show, and I did not know it until 1 week ago. So which is very funny. Okay. The other one, I do know it. I attended a couple of lectures taught by this professor, whom I also don't know personally. He has an online inference, causal inference course, but this book itself is also very, in this GitHub repository, there are lots of data available, and then causal inference, and then I'm pretty sure they have difference in difference somewhere, okay? Instrumental variable regression is continuing. Advanced DID, frontiers in DID. So they have a lot of DID too. So there are slides, there are exercises, there are data. But like I said, this is entirely free for you to access. I did not ask the department to or the faculty to send it over to you because I wasn't thinking about this until I taught my more than business econometry class yesterday afternoon. I was talking to my students about these two textbooks. I wanted to share with you too, but that's it. I mean, these are going to really simply, this mixtape or this, better yet, this one, the effect would actually get to every single thing that you need to know about causal inference. That's it. It's not challenging at all. I mean, it's not like it's not challenging at all. It's not challenging to find great learning materials for you to work on. So I hope this could be another major takeaway from the workshop that we ran today. You don't necessarily have to bother to read master matrix or most harmless econometrics at this point. But if you are doctoral students, if you are someone who is thinking about pursuing advanced study in social science or empirical evidence research, then you can read it later on in your doctoral study journey, year 4 or something like that, to do a little bit more. I mean, to read more examples. Essentially, the example I was demonstrating to you actually comes from mostly harmless econometry. You'll definitely come across it. So this is a little bit more advanced than math, particularly if you're doing a PhD in political science or public policy or economics, etc. Then these two might be helpful to you, but just knowing these two would be good enough for you to do whatever you need to do. So it's that level of, I want to say, sophistication. So and then, like I said, difference is not supposed to be difficult anyways. So that's that. All right. So there are lots of advantages to using differences, but there are also a lot of, I want to say, assumptions you have to make about. Okay. You can include multi-periods. You can look at the treatments with different treatment intensity. You can calculate the standard errors very easily because the software does so for you. You can control other variables too if you need in order to reduce the residual variance. But again, that's a judgmental call you have to make because you have to. So this is just a typical regression model, but oftentimes you see more than just these 3 items. I'll explain this in a little bit, but oftentimes you see, like for example, you could also see like a fixed effects control of time periods, fixed effect control of the observation groups, like the state, for example. You could see that, or you could actually include other additional covariates as you see fit, depending on what your question is, what available variables that you may have, etc. So the treatment, again, is the dummy if the observation is in the treatment group, and then the post is going to be the post-treatment dummy. All right, so this is basically the regression, just to be specific. This is, again, New Jersey is the state. This is the treatment. This is the interaction term that we are talking about. This is interpretation of that. This is the most important takeaway from difference in difference idea, okay? If you look at this regression, if we decompose them into 4 different parts, which is 2 separate differences in differences, this is what we have here, okay? So this equation has the following values. If you just have, let's say, the control group is going to be the state of Pennsylvania, then before the treatment, that's going to be, everything's going to be 0. New Jersey, that means 0 because you're looking at Pennsylvania before the treatment, and the treatment is not going to be in fact at all. So D is going to be 0. That gives us what we have, alpha. That's it. So that's actually the value of alpha, where alpha comes from. Now, if you are looking at Pennsylvania post-treatment, the other thing that changes to 1 is going to be what we call this treatment thing, which is D, and that gives us what we call alpha plus lambda. Okay, alpha plus lambda. And then New Jersey is the same thing. You would actually do, I want to say, the same way of plug-in calculation. New Jersey is going to be 1. but treatment is going to be 0 because this is before treatment. So you would have alpha plus rho, and then you would have New Jersey post, you would have 4 coefficients. So what you do, this difference estimates, is that you're going to subtract, first of all, the differences of the same observational group, which we call treatment group and control group, the differences of each one of them before and after the treatment. That's the step number 1. Step number 2, you're going to subtract the differences from the state level differences between the different periods, or New Jersey different periods. Then that will give you what we call the interstate coefficient, which is rho. Okay, which is rho. So this is what we have, and that's it. So I want to say this is kind of like the most important idea of the regression difference in difference thing. And then you can work on that data, and then to put them in a graph. They observe the data. To put them in the graph, the label supply, the treatment, and then this is what we have, looking again at 2 different time periods. That's before the implementation of the minimum wage effect, and then this after that, looking at 2 different states, Pennsylvania and New Jersey. This is what we have. Now, one of the important assumptions is that you would have parallel consistent movements, hypothetically, if you have a counterfactual group, and then you have the that's your assumption. So you can actually get to the stage of a treatment effect, and then the labor supply would actually change, which is the employment level, because again, we're trying to identify the impact of minimum wage on employment, and which is looking at the interaction term of the state and also the 2 different time periods. So this is looking to putting them in a graph, and what we are able to observe. Essentially, what we're interested in observing is going to be, this is the treatment, this is the control, and then we're looking at the difference in difference, which is represented by the red difference. I guess the red scope of rho. Okay, so once again, the key assumption is that you have common trend. There are many different ways of calling this. You can call it like common trend or consistent trend or whatsoever, but you feel free to, I guess, you have a different ways of variations of what you refer to this as a common trend, is that the outcome in treatment control group would follow the same time trend in the absence of the treatment. This does not mean that they have to have the same mean of the outcome. The common trend assumption is difficult to verify, but one often uses pre-treatment data to show that the trend are the same. This is sometimes, I want to say, a given, particularly in academic research. Not oftentimes this is going to be a condition that will be met, but this is kind of like, a prior thing we wanted to do to make certain that can we use difference in difference approach? Is this going to be an assumption that we can validate? And even if the pre-trends are the same, one still has to worry about other policy changes at the same time. So keep in mind that, like I said at the very beginning, difference doesn't give you everything at all. Even if you have a pre-trend that's going to be consistent parallel, which we call common trends, you still have much more to worry about other than the policy impact itself. Because I'm sure you understand this, like in the state of New Jersey, in the state of Pennsylvania, the impact on employment, comes with many factors. Could be the minimum wage, it could be lots of other things. Okay, so that's that. Again, this is a little bit more complex. Looking at leads and lags, etc. But this is like leads lags analyzing factor increase the employment protection on the firm's use of temporary help workers. This is just another example. You can read about it, but the most straightforward interpretation of difference is what I have demonstrated to you. Okay, there are a few more papers, but I guess I'm going to have you look at it yourself later, including this one. With Bertrand Duflo, and then I don't know this author, I know the first two. This solution using a block bootstrapping standard error. This is a bit more advanced, but I want to say, again, this is using difference, but you are actually looking at state fixed factors to control the within group variation. So this is another a bit more advanced difference, but you can to deal with the standard errors in different strategies, practical solution. You can look at that. later on, but I wanted to make it, I think this is most straightforward to understand in some way, but also a bit challenging if you don't have the fundamental understanding of difference as of yet. Okay, this is another demonstration of using difference to study the effect of terrorism on economic growth. Okay, and then the setup once again is to look at the kind of like a natural experiment. Okay, there's a beforehand, there's going to be a similar time trend looking at two different countries, and then afterwards, given the impact of terrorism, and then there's going to be a difference in economic growth. So they're trying to identify how much change has been, how much has changed given the terrorism change. So there's what we call the synthetic control method, which is interpretation of difference in math specifically, so you can look at it, and then constructing the counterfactual will be using the weights. This is a bit more sophisticated, but the idea is about without actual terrorism, with terrorism, etc. So this is it. So you could do many things with D&D. Just to give you a heads up. You can do D&D using instrumental variable. Like I said, you can do D&D using propensity score matching. You can also do D&D with fixed effects. So there are lots of different things, but these are just, I want to say, examples for you to refer to later on as you see you need them, but not necessarily something we will do. Okay, I make them available just because I want to say it's better to give you more information than less. But what we will be doing now it's very simple. Okay, it's very simple. You probably will like it better than this. Okay, so I'll stop doing that. I'll just by working on this right now with you by looking at this example, and I have asked the department to send it, the faculty to send it to you already. So this is a step-by-step estimation. But like I said, the most important thing would just be to interpret the table. But we'll come to that bridge when we get to it. But for now, let's just do a quick, I want to say, copy paste and load up the data and see if you have any problems. Okay, so you could simply just open up whatever versions of R you have. By saying versions of R, I mean whether you're using a Mac or using a Windows, just open up your RStudio and then let's begin. We can just do copy and paste. Do you want to close this file now? Yes. Wow. Okay, this is a lot that has happened. This is probably before what I was doing. Okay. Yeah, close this file. All right, I'm just going to do a new R script, which is simple and easy. I'm going to load the data first, just so you have the data. I don't think, yeah, I can actually do this. Okay, I can do. This is just to get data from the library. If I click on Run, this is it. So the data is loaded. Now what I need to do is to get the actual sample data. Again, you can run this line. Okay, you got the data now. What you want to do now, as what I showed you, is to create what I call a dummy variable to indicate the time when the treatment started. And then you can work on my data versus time. This is create an interaction term. Made it available for you to just copy paste. If you do this, you can run that. Okay, this is your data. Now it gives you, if you want to observe it, this is going to be the actual data from various years, and then you have different variations, and you have different observations, and also different covariates. Okay, different covariates. So, all right, so that's that. Now, what you need to do next is also create a dummy to identify the group being exposed to the treatment. And then in this example, we are assuming the countries with code 567 are going to be in three different groups, okay, in three different treatment groups. So you only can skip this one if you have them identified already, and I do not, so I'm not going to skip this. So I'm just going to highlight all of them and I'm going to run it, okay? Following this, I'm going to create another, what I call interaction term between time and also the treatments, okay? Simply copy and paste it into another line. Highlight some of that, click on run. All right, now this is found. I cannot just highlight partial of that. It's not like stated, so I forgot about it. All right. Lastly, what I need to do is this is the code, this is the command itself for difference in difference, which is just did rec. It's as simple as that. And then notation lm and treaty time and did, the data is using my data, and that's it. Okay, so but what's happening with R is that it won't automatically give you the outputs unless you do one more step, which is to summarize the outcome. Summary did reg. That's it. So this is the table. If you were to compare it, this is called linear regression. This is the regression treatment time difference in difference. This will give you the coefficients and everything. Your did would be the last line of interest. Okay. Notice that it is a bit small. Okay, it's a bit small. So it's in scientific notations, but you could actually change that later. But this is kind of like the coefficient for did is what we are interested in learning, and then it is significant at the 10% level with the treatment having a negative effect. It's just so it's a negative effect, but it's still significant at the 10% level. Okay, so all right, why don't we do the first 9 lines first and see how it goes? Okay. Why don't you just go ahead and do the first 9 lines and see if you can actually come down to this table. If you can, wonderful. Okay, that's what we are hoping to achieve for now. Can you do that? It should be very straightforward. You can just do that, and then if you want to. If you don't want to, that's fine. I mean, you can do it later when you want to, but I would suggest you run it now. And then see if it works. If it doesn't, let's see if we can fix the bugs. Okay. I'll give you like a 10 minutes or so to run it, to run from line 1 to line 9. Okay. Oh, and I forgot to ask, do you have any questions for difference in particular? I mean, I did not even ask where you come from or what is your background in. How many of you are like graduate students? A graduate student, I mean, doing postgraduate program, either top program or research. Okay. Oh, great. Okay, the majority. How many of you are undergrads? Not many. Okay. How many of you are pursuing a doctorate degrees here? Some of you. Okay, great, awesome. Did what I say make sense to you, or you don't understand what I'm talking about? You know what is difference in difference, right? Okay, all right. Well, like I said, this is not going to be a one-time thing. It's going to take time to know it, but what I'm hoping to do for you is to give you this quick example to demonstrate what I want to say, and two, to provide you as much resources as possible, and then you have to do it on yourself, I mean on your own, okay? But basically that's the nature of doing graduate level work anyways. Like, you know, I don't necessarily think I had great dissertation committee, okay? Amazing professors who actually not necessarily taught me, but guided me, okay? I did all my own work with my peers. We helped each other to learn, but we really have to learn. And then I think the professors are there. I wouldn't necessarily ask the professor to teach me anything about data at all, because she wouldn't have the time to do it for me either. I mean, it's New York City we're talking about, and so everybody has a million things going on. But what she did for me was similar to what I'm doing to my students now. We'll provide as much resources as we can for you. But the convenience of learning today is that there are too many online resources to refer to, and people spend the time to record videos and to teach you. If you have the patience, but it's a very lonely process. But I mean, doing graduate level work is lonely anyways. I mean, I'm sure you know the nature of that when you sign up for the ticket. But there are many. And speaking of the last professor who does this causal inference teaching thing, this one, if you are interested, I'm pretty sure he has no, I mean, it's from Seattle, YouTube. He has lecture but don't laugh, it's funny, but this is, you know, this is he has lots of this is the he has lots of, oh, there we go, look at this. This is a lot of things using R for free. You just have to Google it, okay? But all of these are very short videos. This is within variation and fixed effects. Difference. Look at this.
Hello. In this video, we're going to be talking about difference.
So you can, you know, this is a kind of difference. If you don't know anything, you can look at this, and then this is the application of R. I don't even know this. I mean, you can do this, but there's even textbook accompanying videos on this too. So yeah, there's a video series. Look at this. There's a video series. You can certainly. Yeah, wow, he has lots of them. Look at how excited he is. Let's see if you have any difference thing. There's even probing and logic. I mean, if you are, I mean, the reason you come to this workshop is because you wanted to learn about causal inference. But I mean, I guess, you know, by learning this resource, it's going to be tremendously helpful. If you have any questions, feel free to email us. I mean, I'm happy to send this over to you, but it's publicly available, so you don't need me to send it to you. You can actually do, if you're doing graduate level work, it's actually your job to do it. This is just from 1 year ago. Like I wasn't really lying, because I just found out that this is episode 51, 52, 53, 54, and 55 are all relevant to difference in difference. Okay. I watched the first two. I want to say I remember I watched the first three actually yesterday. But I did not watch the fifth one and the sixth one. You can look at it too. I mean, even the sixth one, 51 to 56. I think that's just very very helpful. Okay, it's just very helpful. I think you can do this. All right. Lots of them available. You can play around with it if you want to. Okay, so were you able to get to this table? Everyone, were you able to produce this table for sure? Yeah, okay, excellent. All right, the very last step is to make sure you know how you interpret the coefficients. Like I said, this is going to be significant at the 10% level, looking at the p-value. Looking at the t-value here, and then it is significant at 10% level with the treatment having an effect, but it's going to be a negative one. But this is scientific notation because it's really small. But this is what we are looking for when we are looking at a study like this. Okay. All right. So the very last thing is estimating the DID estimator using the multiplication method. No need to generate the interaction. What do I mean by that? This is basically, I mean, similar to what we had before. Not necessarily exactly the same, but similar to what we had before. It's just that, instead of generating here, we generated what we call a interaction term first in advance. So we generate the interaction term, which is the DID thing. But if we don't do that, we can also come across this by doing, but it's a different code. It's called DID reg 1. What we did is we'll just do this, same data set. Of course, you need to summary. Okay, if I highlight both lines and run it, DID1, this is 12, and that's it. So it's actually exactly the same result. Residual standard error is the same, and then you can do it, and then the summary results give us about the same thing. Okay, now here, the coefficient for treatment times time is the difference estimator. The DID in the previous example, and then the effect is significant, again, significant at 10% level with the treatment having a negative effect. Okay, so that's that. All right. Okay, so here are the couple of references. The last one doesn't work, but I sent it over to you already. That's the slides I have. This link is out of date, so I took off that. This one is not necessarily a PDF document at all, and I think this is a little bit more complicated. This is kind of like a difference estimation academic seminar. But if I were you, I would just stick to this new resource called the effect and watch from 51 to 56, and that should be it. Okay. Any questions for me? Yes.
My question actually exaggerates a little further from difference in difference.
Okay.
In classical difference in difference, the treatment should have happened on a single time point for everyone, right?
Oh, single time point for everyone in both the treatment group and control. In the treatment group, okay? Yeah.
The research I'm thinking of is on the market impact of properties that have experienced typhus or floods. And looking at kind of a longitudinal study, so there are multiple flooding events, each would impact kind of a group of properties. I wonder in that scenario whether we could use difference in difference.
I think you can, but if you're talking about multiple periods of natural, well, that's a natural event, which is what your treatment is. You may want to, let's say, specify. I guess first of all, you don't need to specify your treatment control group because that's actually being impacted by the natural disaster or not. But you have to specify the time period, like how long are you looking? How much further in advance you're looking at, or how much further back you're looking at, because what you want to avoid is that you actually have two treatments, meaning that you have disaster one, natural impact, and then you have disaster two. That might complicate the nature of the difference design, which could be, I want to say, a difference in difference, but that's kind of like, I want to say, even more complicated than what it should to be. So as long as you define, I want to say that if I I probably would actually just specify the time period you are looking at, and then in between there's this one you call that intervention, you call that, well, that's not necessarily intervention, that the natural disaster event, you can do that. You can then ideally you can do this difference, but you probably in the process, I mean, you may want to, given the context that you're looking into, you may want to control, let's say, a certain type of a certain variable as a fixed effect too, if you choose to do so. Does that answer your question?
Yeah, so basically, by looking at all the disasters that happened in a single year.
Yeah.
And compare 5 before and after.
Correct. Yeah. And then your price would be your treatment outcome. Looking at Y1 0. I mean, not Y1. Y1 treatment, and then also Y0 control. Those are the two prices that you'll be looking at, and then but you'll be examining these two groups separately. Okay. Yeah. Great question. That's kind of like, I want to say, application of the that's the application of the study. Okay. Any other questions? Yeah.
Question actually is similar to the previous one.
Okay.
I noticed that in this code we are only allowed to compare the difference from 2 time points.
Yes.
But if I have more than 2 time points, I have like a lot of them, but each of we have equal intervals to each of the time points. Can we do those difference at once?
You can do the different, that's kind of like the multi-period. So that's a good question. That's a very good question too. If you notice what I was saying here, you can actually, this example is not like a multiple time periods intervention, but for one of the advantages of using difference is that you can do that. You can do more than 2 time periods. I said, hold on 1 second. Actually, not this slide, but the other one, which is let's see, this one, yeah. One of the advantages of using DID is that you actually can do multiple periods for sure. Multiple, but that would be again for a bit more complicated model. Yeah, right here I said you can include, you can definitely say, so this is the basic model of that. This is the basic model. The example we have is that just for simply case demonstration purpose, we have 2 periods like pre and post. But you can definitely include more time periods for sure, and easy to you can incorporate multiple periods as well. And then for different periods, and then you're looking at the treatments with different treatment intensity. That's also fine. If you are for example, again in this case, if you're looking at the you have like not just like a specific increase in minimum wage, but you're looking at a varying increase in minimum wage for different states, that's also fine. Like multiple states, multiple periods, that's also considered to be okay. It's just like the example we have here are showing you 2 states and then 2 time periods for simplification purpose, but you can do more than this. So that for that, sometimes you call it like a difference in difference, but you have to define the nature is still difference in difference. It's just like in a way you decompose them into I want to say several difference in difference before you can incorporate like multiple periods. But essentially it comes down to the 2 periods, but beyond these 2 periods, you can add on additional periods for sure. I don't have an example available right away, but I could come up something like that for sure. Yeah.
Okay, one more question for the technically we are creating something variables in the R coding.
Correct.
So we have multiple periods. We have to do it for several times, and each time we create 2 values.
First of all, you don't necessarily create a dummy variable. I mean, it is in a data set. If you look at the data set, it is the nature of the data set is going to be it's given. I mean, you don't necessarily create that anymore. So this is kind of a time period 0, which means before time period 1, which is after, and then for treaty 0 is going to be not being treated, and then 1 is going to be treated already. And then what you really created in the process is that we created this interaction term of time and also treatment, which gives us the difference in difference thing.
Yes, I understand, but, for example.
If you have multiple periods, do you create more than that? Is that right? Yes, you do. Yeah, you do. Yeah.
I have another question, like, if we have, different time points, and in the time column, we have like 1, 2, 3, 4, 5. And in the treated column, we just have 0 and 1. And, actually, when we create the available IP, we only get 1, 2, 3, 4, 5, and a lot of zeros.
You probably have to create for different time period. You're going to create, I want to say, a dummy for that specific time period before and after. That specific time period before and after. You would not necessarily do, like, I understand what you're saying. You wouldn't necessarily do 0, 1, 2, 3, 4, 5. That's not going to work. I mean, that you wouldn't be able to create an interaction term just based on treated and time. You have to separate them to different time periods to do that. Yeah, so just to clarify that, and also again define the different time periods, and then so that's where it gone to a little bit more complex. But I want to say the fundamental thing is to have like a you decompose it. Eventually, even if you have that multiple time period, I ran into a scenario like that before. I know exactly what you're saying, and then you have to decompose it to the essential stage of looking at comparing 2 time periods first, and then go beyond this and interpret that. So I think the lesson I learned was to again make certain I know exactly what I'm comparing, and then make certain I know the common thread holds in what time periods. And then when I'm coding this, now I haven't coded like multiple periods in R before, but when I was coding multiple periods in Stata, I wanted to make certain that the variable as a create do not conflict with the one I had before. Otherwise, the coefficients I have would not necessarily make enough sense. Yeah, but I do want to follow up on this later and see if I can come up with another example showing multiple periods. That would be better. So I'll look for it. I think there are plenty examples of that. It's just like, for this demonstration purpose, I wanted to go simple, as I don't want to confuse myself. Okay. All right. Thank you for asking the question. Pretty helpful. All right. So. Okay, so I'm gonna have you keep working on this, but this is pretty much it. This is an example I'm trying to demonstrate to you. Once you do this, and then you should be good. I mean, as long as you can produce these 2 tables, I am very happy with that. The only thing I want you to, so that's it. I'm gonna stick around and have you ask questions, and if you don't mind, just help us fill out this survey and tell us, giving this practical example with some kind of like, introduction to the difference, or regression discontinuity, or anything in the future. Is this okay? Like, is this way of teaching a workshop like this makes sense? Like, does it help? If it doesn't, tell me why. That's going to be highly appreciated. Okay. Yeah, but that's it. You can take a look at it, and then keep working on the practice. And then if you want individual tutoring help, I'm around to help you. All right, and then but fill in the survey before you let yourself go. But that's it. Not too long. It's a very short workshop. I don't have a typical a lot, but the rest will just be for you to practice on the examples I provided to you. Okay.
Alright, based on the code, it looks like it's looking at interaction effects. So,
You're looking at what?
looking at interaction effects.
Which is the difference in effect? Yeah, which is exactly the difference.
The legislature going through, they talked about the other ways of estimating percent error. So why do you think other ways of estimating error?
That's just to take care of if you have a specific standard error concern or issue, then you use other approaches to do that. For example, you may choose to. Well, this is very simplified. You're just looking at 2 time periods, looking at 1 treatment. But what about if there are other covariates that you wanted to include, or you want to control the within group variations? Then that may either reduce your R square, which is the portion that's being explained, or increase it. So you might want to do a justification, and then you want to look into the standard errors to see if it is a balanced thing. So that you adjust that accordingly based on what you are studying or your question. So there could be a lot of different variations, but this is kind of like everything can apply this because it doesn't interfere with any other further complications. That's it. Yeah. Okay.
Did you also test for Stiglitz method?
Test what?
Test for Stiglitz method using log like
You can do that.
You have a model with interact feedback, without interact feedback.
Yeah, you can do that too. Yeah.
Thank you.
Yeah, you're welcome.